Okay guys, today our next lesson is going to feature another part of number patterns, or recognizing relationships between numbers. And today's focus is going to be on something called input-output boxes. I've heard them called function boxes before, or function machines, even though they're not really a machine, but I've heard them called different things before. But what you see there on that picture right here, that's what they look like. They have a number in the in column, a number in the out column, and sometimes there's some missing numbers, and you have to figure out, how do I get from the in number to the out number? And that pattern should apply for all of the numbers in the box. Okay, and so we're going to go ahead and get started. Okay, so with the in boxes, we have the input and the output. The inside of the box is where you always begin, and something happens in the middle to get you to the outside box. The outside of the box is what we get after we determine the operation. So just like in a number pattern, we're going to be either using addition, multiplication, subtraction, or division. Okay, you can kind of think of an input-output type device as something we have in real life. So like, for instance, like a gumball machine. If we put in a quarter, out comes a gumball. Okay, so the input is in the quarter, out comes the gumball, something happens in between to get what we want. And that's kind of like what a function box or an input-output box is kind of like. You have to look at the in and the out and determine what happens. Okay? And so if you guys will look, there's a website that I will give you guys as a separate assignment that you'll be able to click on and go to and practice this concept too. Okay, it's a fun little function machine, it's called. Okay, so for today, let's look at this first example here. And how I work input-output boxes is I always look at one of the numbers and determine, how do I get to the other one. If you'll notice, this is the part that I'm missing. So I have to figure out where my question mark is. I have to figure out the number that's missing for my input-output. Okay, so I'm going to use these two sets of numbers here to get me started. How do I get from 4 to 7? Well, I know to get from 4 to 7, I can add 3. Okay, so I can check this answer by looking at my last set of numbers, because I have both an input and an output number in this same row, to see if that add 3 rule matches up. So if I have 8 and I add 3, do I get 11? Yes, I do. And so then, if that's the case, since it works here and it works here, that means that my rule must be add 3 for this entire input-output box. So if my rule is add 3, if my input number is 6 and my rule is to add 3, what would my output number be? If you said 9, you are correct, because 6 plus 3 equals 9. Okay, let's look at another example down here. Okay, here, sometimes in input-output boxes, you can have multiple numbers missing. And if that's the case, then you have to fill them in both. But just like the last one, I have to look first at what they give me in order to figure out my questions. Okay, so how do I get from 6 to 18? Well, from 6 to 18, I know that I can times it by 3, and I also know that I can add 12, because 6 times 3 is 18, 6 plus 12 is 18. So now let's look at this second set of numbers. 8 and 24. These are two numbers that I know. I'm going to try both of these rules with 8 and 24 and see if they work. Okay, can I do 8 times 3 and get 24? Yep, that's a true statement. So, but I'm going to go ahead and check 12. 8 plus 12, would that give me 24? No, it wouldn't. 8 plus 12 gives me 20, so that one wouldn't work. So I know for this box, for this input-output box, my rule has to be times 3. So if that's my rule, if my input number is 5, what is times 3? 5 times 3. That means my output number should be 15. If you said 15, you're correct. Good job. Now let's go down here to this one. 10 is my input number. What would my output number be? If you said 30, good job. Nice job. Okay, let's look at the next one. Okay, here I have another set of input numbers, but it looks like here they seem to be decreasing. They're getting smaller. So remember that our options for when numbers get smaller, they're subtraction or division. Okay, so I know that 35 can't be divided by something to a number we can work with to get 31. So I'm going to go ahead and try an easier one and try subtracting first. 35 subtract something should give me 31. Well, I know that 35 minus 4 should give me 31. So I see down here in the bottom of my input-output box I have 2 more numbers, so let's try that rule and see if it works. 6 minus 4, do I get 2? I sure do. 6 minus 4 is 2. So now I know that my rule has got to be, minus 4. So let's apply that to the missing numbers that I need here. 20 minus 4, what should I get? Everyone, mental math in your head, 20 minus 4. If you said 16, great job. Now you're going to take your next input number and apply the rule. What is your answer going to be? If you said 8, great job. Very good. Okay, going down again. Okay. For this first row, I don't know what this one is, so let's look at what we do know. 60 and 30. 15 and 7.5? What? 7.5? How in the world am I going to work with that? Okay, you know what? I'm going to forget this 7.5 for right now. Let's just go back up here to these two numbers. They're probably easier to work with. Okay, so I know that I see my numbers are decreasing. So 5th graders, when your numbers are decreasing, ask yourself, what 2 operations do you use when numbers get smaller? If you said subtract or divide, you're right. Very good. Okay, so let's start off with subtraction. 60 minus something equals 30. So 60 minus what equals 30? If you said 60 minus 30 equals 30, very good. You're right. Let's go ahead and let's try the division one too. 60 divided by what equals 30? If you thought divide by 2, you're correct. 60 divided by 2, or divided in half, is 30. Okay, since I have another unknown here, I'm going to go to that dreaded 7.5 one, and let's see what we can do with that. I don't know. All right, let's look at our 2 options here. We have minus 30 and divide by 2. Yikes. 15, can I take away 30 and get 7.5? Holy cow, no. I can't do that. All right, let's try this divide by 2 thing. 15, if I divide it in half, am I going to get 7.5 or 7.5? Remember that decimals mean the same, decimal 0.5 means the same as a half. So let's check that. 7.5, plus 7.5. Sorry for my writing, guys. Well, I know 7 plus 7 is 14. I know 1/2 plus another half is another whole number, or 1. So 14 plus 1, oh my gosh, that gave me 15. So gosh, my rule must be divided by 2. So if I know that my rule is divide by 2, now let's go back and figure out these remaining 2 numbers. 80 divided by 2, what would that be? Or 80 divided in half. If you said 40, great job. Let's go to this one now. 30 divided by 2, what would that equal? Or 30 divided in half. If you said 15, great job. Nice job. Okay. What I want you guys to do on this box, pause the video for a moment, and in just a second I want you to pause the video and I want you to look at this input-output box and solve for what the rule is. All the numbers are present, so you just need to look across and figure out what the rule is. And when you unpause the video, you should be able to see if your answer matches mine. So go ahead, pause the video, and I'll see you in a minute. Okay, we're back. So if you said that the rule was multiply by 4 each time, you're correct. Good job, because 4 times 4 is 16, 9 times 4 is 36, 12 times 4 is 48, and 7 times 4 is 28. So each one of these follows the rule of multiplying by 4 each time. So my rule for this input-output box is times by 4. Okay, let's take a look at this next one. This time I have a missing number and my rule is missing. So again, we're going to do the same thing. I want you to pause the video, take a look at these numbers, and see if you can figure out what the missing number is and the rule. Okay, so if you need to copy them down, go ahead and do that now, but I'm going to pause the video. I want you to pause the video and see if you can't figure it out. Okay, good luck. Okay, how'd you do? Does your box match up with mine? Hopefully you determined that this missing number here was a 1, because if you looked at 9 and 4, you could have said, okay, I know I can subtract 5 here. So let's see if the subtract 5 matched for the other parts of the box, and it did. 12 minus 5 is 7, 18 minus 5 is 13. So when you take that rule minus 5 and you bring it to the 1, your rule should be subtract 5. Okay, let's go to the next box. Again, we're going to follow that same process. This time I have a missing number on my input side. So you're going to have to think and kind of reverse your thinking just a little bit, or do an opposite of what the operation is. So if my operation, see how they're getting bigger? I might have to use some subtraction to figure out that number. Okay, that's your only little hint there. Okay, so I want you to pause the video. Again, you're going to need to figure out the missing number and the rule. So go ahead and pause. Okay guys, looking at your answers now, if you came up with a missing number of 3 and the rule of adding 6, you're correct. Now let's talk about this one for just a second. Okay, you should have been able to use the numbers that you had given in the input-output box to help you figure out the rule. 9 plus 6 is 15, 8 plus 6 equals 14, 12 plus 6 equals 8. And then I know that my rule is plus 6, but I was already given my output number. So I kind of need to do some backwards thinking. I either need to ask myself something plus 6 equals 9, or I know that the opposite of adding 6 is subtracting 6, so that means 9 minus 6 would give me 3, or 3 plus 6 equals 9. And so that gives me my rule of adding 6 each time. Okay, there's going to be a couple of quick questions at the end, and we'll talk about this tomorrow more in class. See ya!